Welcome back. Now that we have spheres and we've determined at least some of their behavior, it's time to create some kind of actor that can spawn these spheres in at regular intervals. I'd like a sphere spawner of sorts. So I'm going to go ahead and delete this BP small sphere, and I'm going to make a new actor for spawning these. We'll go ahead and go into our blueprints folder, and these can be in the small sphere folder as they're related. I'm going to make a new blueprint class. It's going to be an actor, and we're going to call it BP underscore sphere spawner. Let's go ahead and open up sphere spawner. Now, sphere spawner is simply going to be an actor that spawns sphere actors. It's a sphere factory of sorts. Now, if we take one of these sphere spawners, which so far is just an empty actor, and drag one into the world, we can see that there's an actor here. And my goal is to spawn spheres somewhere in the vicinity of this sphere spawner. In other words, I want to imagine an invisible radius around this spawner, and I want to spawn spheres in that radius every so often. Now, to visualize that sphere radius, we can draw a debug sphere. So just while we're developing, to make things easy, I'm going to use event tick to draw a debug sphere. We know how to do that. Draw debug sphere. We're going to do this every frame, so we don't need a duration. And the line color can be white. And the radius, I'd like to promote to a variable so that we can use this radius in our sphere spawning endeavors. So I'm going to promote to a variable and call this spawn radius. Now we can make spawn radius instance editable if we like. We can compile and make sure that it's set to 100, but I'm going to set it to a value of about 250 for now. And we can give it its own category. I'll give it the category of sphere spawner. Now we're drawing the debug sphere, but we're drawing it at the origin. We want to draw it at our sphere spawner location. So we can call get actor location and pass the actor location in. So let's take a look at what that looks like. And there's our sphere spawner. So we can always adjust that spawn radius if we want it to be bigger or smaller. For now, I'll leave it as is. And I'd like to focus on getting random points within this sphere. So how are we going to get a random point inside the sphere? Well, we've seen that we can get a random rotator by searching for random rotator. Well, if we have a rotator, we can get a forward vector from the rotator. There's a function called getForwardVector, and this is from the vector math utilities. Now we can select getForwardVector, and this function requires a rotator. So this is different from getActorForwardVector. GetActorForwardVector is a function on actors that returns the forward vector of the actor itself. GetForwardVector returns a vector corresponding to a rotator passed in. We're going to pass in a random one. Now that we have this forward vector, we can scale this by some distance, but I want it to be a random distance within a range. So I can use one of the random number generator utilities, random float. And if I choose random float in range, I can provide a minimum and a maximum for this float value. And I want a random value between 0 and my spawn radius. So the spawn radius will go in as the max. And my forward vector is going to be multiplied by this random value in range. So I'm going to convert to a float and hook this up. And we now have this vector, which is a vector pointing in a random direction with a random value between 0 and spawn radius. So what can we add this to get some point within the vicinity of the sphere spawner? That's right, we have to add this to the sphere spawner's location. So we can get actor location, and we can add these two vectors together. So add gives us this location. Now, this whole calculation could be a function. In fact, it could be a pure function. It's just using a bunch of pure functions, and it itself could be one pure function. It could be called something like getRandomPoint within our sphere radius, something like that. So I'm going to make a new function over here under functions. I'm going to click plus to add a new one. I'm going to call this getRandomPoint in sphere radius. And I'm just going to paste those nodes in. So I'm going to go back to the event graph. I'm going to Control X to cut them. They're now copied, and I can go back to my new function and paste them in. And my new function is going to return a vector. So if I click on the purple input node, I can click plus for my outputs, change its type to a vector, and call this random point. And it's going to be fed the value from this calculation here. I'm going to pass that straight in. And now if we call this function, we'll get that random point. Now, clicking back on the input node, I'd also like to check pure, because this is perfect for being a pure function. And now if we go back to event graph, I can call that function, I can bring it in, and we have this pure function returning a random point. And on begin play, I'd simply like to draw a debug sphere to see what this looks like. So let's draw a debug sphere. I'm going to use the random point as its center. I'm going to hook this up to begin play. I'm going to draw this for a duration of 60 seconds, and I'm going to change its line color to red, reddish, and change its radius to about 15. And now we can test this out. Let's go press play. And there's the random point. But if I hit stop and press play again, the random point is different, and it should always be different. It shouldn't always be at the same spot. As we can see, it changes each time we call the function. Excellent. So now we have a way to get a random point in our sphere radius. But I don't want to just draw debug spheres. I want to spawn instances of our BP small sphere class. And I'd like to do this periodically, every 2 seconds, 3 seconds, however long we decide. In fact, we can come down to our My Blueprint panel and add a new variable called spawn time. We can make that a float. We can compile and initialize this to a default value of, let's say, 2 seconds. So every 2 seconds, I want to spawn a small sphere at a random point. By the way, I don't need event actor begin overlap. I'm going to delete that. So I want you to think about it for a second. How are we going to spawn in a sphere every 2 seconds, or whatever our spawn time is set to? This is going to be a challenge for you. So your challenge is to spawn in a BP small sphere every spawn time seconds. If spawn time is 2, I expect to see a new sphere every 2 seconds. And I want it to be spawned in at a random point within our sphere radius. Remember that timers are better than delay nodes. So a hint for you is that you should be using a timer. So pause the video and implement this feature now. Okay, so we're done drawing debug spheres. We want to do something more interesting. We want to spawn things, and I'm going to use set timer by event. I'll go ahead and hook that up to begin play. And we need an event. So making room, I'm going to make a new custom event and call this spawn small sphere. We'll hook that up. And we need to use our time, spawn time. I'll go ahead and put that into time, which, by the way, spawn time could be added to our sphere spawner category as well. Now, my timer is going to be looping. So every 2 seconds, it'll call spawn small sphere again. Now I need to spawn the sphere, right? So I'm going to get a spawn actor from class and select the class BP small sphere and hook this up to the custom event. and we need a spawn transform. Now, what I want to do is split the struct pin for spawn transform and pass in the random point for the location, and I don't need to worry about the rotation because these small spheres are changing their own rotations randomly, so I don't need to worry about that. All I need to do is spawn the actor. That's it. And the spheres take care of their own lifetimes as well. So it's kind of a spawn and forget situation. So now we can test out our sphere spawner. I'm going to go ahead and press play and sit back and watch. There's one. There's another one. There's another one. Excellent. Now, one thing I'm noticing is they all do seem to be pretty much going in the same direction. Now, that's because they start off pointing that way, and they're slowly changing their rotation every single frame in a different direction, but they all initially start going that way, which you may be okay with, but I would personally like them to be starting off in random rotations. So what we could do is we could pass in a random rotator for the spawn transform rotation. I'm going to do that. I'm going to search for random rotator, and I'll simply pass that in for spawn transform rotation. Let's see what that looks like. And now we can see our spheres going in random directions. Excellent. And the cool thing about this system is we can change our variables to see different behaviors. We can go to our spawn radius and set it to a bigger value, let's say 500. We can change our spawn time. We can spawn these in faster, maybe every 1 second. And we can play test and tweak the values. We can move this up so we can see a larger volume. And now we have a larger sphere, and we're spawning more objects more quickly. Now, the lifespans are properties on the sphere itself, so we'd have to go to the BP small sphere if we'd like to see them last a little bit longer. But now we have a spawner. Excellent. Great job on the challenge. It's okay if you didn't get it. This is all for practice, and the more challenges you attempt, the better you will get. Now, I feel like we're done with drawing that debug sphere. We can delete that debug sphere node, and all we have left is setting up our spawn timer. I'm going to comment this and say start sphere spawn timer, and I'll go ahead and set it to a red color and check show bubble when zoomed, and our sphere spawner is done. Great job, and I'll see you in the next video.